Hey guys, so we're going to be doing Virtual Lab 6, which is about the reactions. And I'm going to go ahead and set this up so that we're sharing our screen. And I'm going to go ahead and go into the reactions lab in the student view. Open lab if it will let me. So we're going to go ahead and start this. So this is Virtual Lab 6 reactions. Now, I'm going to go ahead and take a screenshot of this first part just in case I need it. I don't know that I will, but I always like to have those just in case I need them. Here, there's a little bit that I couldn't see on that screenshot, so I'm going to go back. Okay, let's again, because there was a little bit right down here that I couldn't actually see. Oh, sorry, this is what I want. So the right of balance chemical equation, I couldn't see it. So I'm going to take and do just this bit right here, because that's the last part of this that I need. This here, because that's the last part right there. So just in case I need it. I'll go back in here. Sorry, didn't need that. All right, so again, we're going to be looking at the formation of precipitates in this particular reaction, and then we'll be talking about how we write balanced equations for those. So this is important. It's an important part of what we're talking about in terms of reactions and solution, forming precipitates, that kind of stuff, and how we write those reactions. So these are all kinds of reactions that you may see on the test. So they're not for the first test, but in the second test. So we will talk about the balancing equations on the first test, but the predicting of products will be for the second test. We'll balance reaction first test and predict the products on the second. So examine the appearance of each of the solution before mixing. Record the observations in the lab day. Okay. So we're going to be talking about mixing sodium hydroxide and the nickel 1 nitrate. So since I need to show my labels, this is my sodium hydroxide, and this is a nickel 1 nitrate. Okay. So the sodium hydroxide is a clear solution. Call this solution NaOH and bluish solution of NiO3 2. Okay. So that's what I observed. Bluish. All right. So I'm going to mix in the clean test tube, drop or full approximately 1 milliliter of each solution. So I'm going to mix this guy right here, and I'm going to mix this guy right here. And I'm going to see what I get. So what I see is that this is a greenish solution. I've got some stuff there, and it doesn't appear to feel heat. So in my lab data, I want to record my observations. So I see that a solid is formed. And no, it doesn't feel hot, it doesn't feel cold. And then I want to look and say, okay, I know that I made some product. It looks like a solid has been formed in this. And so I have two potential products that I could have made. I could have made an NaNO3, right? So the Na plus goes with the NO3 minus, right? And so that could be one of the solids that I made. Or I could have made an NiOH2, because Ni is 2 plus and OH is minus 1. So it would have been an NiOH2. And so I need to look at my solubility rules. And so I need to look at the solubility table, which is right here. So these are the water soluble compounds, and these are the rules that they've given me. And so I need to take a screenshot of this. So this is my solubility table. I'm going to put this in here. And it says the compounds containing an alkali metal or ammonia ion are soluble. So that NaNO3 should be soluble. I also say the compounds containing the nitrate ion are soluble. Okay, so that one should be soluble. Now the other thing that I see, if I keep looking down here, I see that OH is in the water insoluble compounds. And I don't see that there is anything that says that the nickel is an exception. So that nickel hydroxide should be insoluble. Now, other things that we have in here, it talks about how to predict products. Okay. And we examine each reactant and determine whether the reaction is a double displacement or a single displacement. This would be a double displacement. Determine the products based on the type of reaction. For double displacements, switch the cations and anions. So we take the cation here and put it with the anion there, and the cation here and put it with the anion there. And that's exactly what we're doing. Okay. So that's what we did. And so I'm going to take a screenshot of this just to talk about how we did. I apologize for that. So we'll put that in here because that's how we determine what our products are. Okay. So those are my rules for how I figure out what those products are. So that's important. And then I can look at the activity series. This will help me with some things. So eventually we'll need this. We may need this. So I'm going to take a screenshot of this as well, because I may need to put this in here. Personally, I don't use this a lot, but it's in here so that way I have it if I need it. So now I can close this part. The other thing that they give me is how to balance chemical equations. So these are some rules for how to balance chemical equations. And so I'm going to take a screenshot of this because I may need this at some point. And that way I've got a copy of all of the rules and things that they've given me for doing this. Get rid of that, I can close this out. Now, so I know that I've done a double displacement reaction for this particular reaction here. I did my observations, I made a solid, and my solid that I made had to be that nickel hydroxide. And it has to be an NiOH2, but it's not an aqueous. I made an NiOH2 solid, and I also made an NaNO3 aqueous. And there's one of an Na and an NO3. That's aqueous. Those are two products that I have out of this reaction. So that's what I have for that. Okay, so those are the products that I made. That's the solid that I formed is the NiOH2. And those are the observations. Cool with that. So those are my observations. I'm going to get rid of this. I'm going to zoom out, and then I'm going to put this into the chemicals for disposal. And then put this in the wash. Now I'm going to make some observations about the potassium iodide, which is this one, and the lead-2 nitrate. So I look at both of these, and they are colorless. That one is colorless, and that one is colorless. Come on in. Okay, so we're massing this potassium iodide, which is here, with the lead-2 nitrate, both of these being colorless solutions. We notice that we form a solid and that solid is yellow. So I'm going to make some notes about that. I have both colorless solutions form a yellow solid. Or the white solid there, so sorry. We saw no change in temperature. Now, when I do the ions together, we make a KNO3, both K plus, NO3 minus, so KNO3. K and NO3, looking at my solubility again. K soluble, NO3 soluble, so that's going to be soluble. When we mix the other two, we have our PB 2 plus and I minus, so that makes a PBI2. So our KNO3 is going to be soluble. We have a PBI, so PB2 plus and an I minus. That's going to be a PBI2. When I look at this, I see compounds containing the chloride ion, bromine ion, or iodide ion are soluble except compounds containing PB2 plus. So that's going to be an insoluble. And when I look at that, we have a PBI2 salt. So that's the one that we have there. So clicking that, I'm now going to come out of here. I'm going to zoom out of this. I'm going to dispose that and put that there. Now we have our sodium carbonate, which is this guy right here. He's a colorless liquid. And our calcium chloride, which is right here, he's also a colorless liquid. Zooming in, I see that we've formed a white solid and no heat. So both colorless liquids form a white solid mixture formed. So we're going to have, again, we have an Na plus and a CO3 2 minus. I can see that because I have two NAs. And I have a Ca 2 plus because I have a Cl minus. Now, looking at those, I need to look and see what my products could be. So I know I'm going to have an NaCl and a CaCO3. NaCl, so Na and Cl should be soluble, and a CaCO3. So I don't see CO3 until I get here. CO3 2 minus is water insoluble. Ca is not listed as an insoluble exception. So CaCO3 should be the solid that is formed. So I scroll back up and I see that my NaCl should be aqueous and it should be an NaCl, one of each. So I see NaCl aqueous and Ca 2 plus goes with CO3 2 minus. So that's a CaCO3 solid. Shift, no, this one and to control there. Okay, so CaCO3 solid and Na, no, that's the wrong one. This one, NaCl aqueous. Come out here, zoom out of this, dispose of that, and I'll get rid of that. So now I need the potassium iodide acetate, which is here, clear, again, colorless. And this one, which is a silver nitrate, which is also colorless. And looking at that, I don't see anything, and I don't see anything there. So I had two colorless solutions. Two colorless solutions. And I see no observable change. So looking at this, I have an AgC2H3O2, so those two together, and then a KNO3. Those are the products I would predict. So I know my K and my NO3 are soluble, and then I have the Ag and the C2H3O2. Now C2H3O2 is right here. That's soluble as well, and Ag is not listed as an exception to that. So I have no solid that I would expect to form, no observable change. And so I have an AgC2H3O2. Okay, that's a -1 and a +1. So I have that as an aqueous. And then a KNO3, which is also no reaction occurred. So no products whatsoever is how they're putting it. Now, I'm going to zoom out. I'm going to dispose of this, pull that out, and then I'm going to say I'm going to go to phase 2. So even though I had potentially the displacement on both of those, there's no reaction that actually occurred. So we're going to balance the chemical equations for the reactions of aqueous sodium hydroxide and aqueous nickel 2 nitrate. So I have the NaOH plus the NiNO3 2. So I have one Na and one OH, but I know that when I make that product, it's got to be NiOH2, right? So I have one Ni, one Ni. I have two OHs there, so I need to have two OHs here. And then since I have two NO3s and two NAs, I need to have two over there. Okay. So now I have two NAs here and two NAs here, two OHs here, two OHs there. I have one NI, and then two NO3s, so I have two NO3s. So that should be balanced. I'm going to come down here. I have balance for aqueous potassium iodide and lead 2 nitrate. So I've got one K over here and one K over here. That's good. I have one I, but I have two I's there, so I need to have two K's, two KI's here. So now I have two K's on this side, and I need to have two there. So now I have two NO3s, and I have two NO3s, and one PB, and I have one PB. And so I have two I's and two I's, so that should be balanced as well. I have Na2 and one Na there, so I need to have two in front of this. I have CO3, there's one of those, and one CO3 over here, and one Ca and one Ca. I have two Cls and two Cls, so that looks good to me. So let's try and go on. Oh, awesome, everything is good. Yes, I love it when that happens. So we're going to do the same thing here. We're going to examine the appearance of each of our solutions before mixing. I'm going to show these. This is sodium carbonate and nitric acid. I'm going to take my sodium carbonate, which is colorless, and my nitric acid, which is also colorless. Mix them together. And what I see is that I form bubbles, and it's warm. Okay? So I'm going to open this up. I have two colorless solutions, form bubbles, and heated when mixed. So bubbles form in the mixture. Test tube feels hot. So what are my products here? Well, okay. So I need to look and see how do I predict the products. So let's go look at that. And I know that this is not this could be a double displacement. So I can look at what my products would be when this happens. So I'm going to have my HNO3 that I react with the HNO3 and Na2CO3. HNO3 and Na2CO3. So HNO3 plus Na2CO3. So I'm going to have that H go with the CO3. So since this is CO3 2 minus, I need to have two H's go with it, right? So it's H2CO3. And then the Na is going to go with the NO3. So it's an Na plus and an NO3 minus. So it's NaNO3, right? So what I'm looking at is that NaNO3 and then H2CO3, right? So those are the two things that I'm looking at for those particular products. And one of the things I need to know is that H2CO3 can spontaneously decompose. H2CO3 spontaneously decomposes to become CO2 and something else. And so if I look at what else it's going to be, I get CO2 and H2O. Those are the two things that I get. And what I'm talking about, I'll show you. I'll skip this, sorry. So again, the reaction that I'm looking at when I talk about, I was looking at Na2CO3 plus HNO. That was what I was talking about right here. And so I could pull this back up. That's what I've got written down right here, right? And so I do my double displacement. The Na from here comes Na. And so we're here with the NO3. And the CO3 comes over here with the H. And of course, since it's an Na plus and an NO3 minus, I get an NaNO3 plus an H2CO3, because it's a CO3 2 minus plus the H2. So 2H plus. Now this H2CO3 spontaneously decomposes and it becomes an H2O plus a CO2. And this just happens with a little tiny bit of heat. All it takes is a little tiny bit of heat. And it turns out that room temperature is enough to make that happen. So I get H2O and CO2. And that's what's happening in Speaker when we're looking at this. Okay, so I'm going to minimize this. So that's what I get out of this. Now, select products. So the products that I get out of this are CO2 gas, H2O liquid, and then the NaNO3. Those are my products. Now I'm going to minimize this. I'm going to zoom out and I'm going to dispose of this. And get rid of that. Cool, that was fun. So now I need to know, where is the sodium hydroxide? Well, that's this guy. He's a colorless liquid again. Put that back in there. I'm going to mix that with the nitric acid, which is this guy right here. Both colorless liquids. Tube feels heated. Two colorless liquids. Tube heated upon mixing. So 2 feels hotter. And so the question becomes, well, what are those products? So again, I had my NaOH, sodium hydroxide, and that nitric acid, which is the HNO3. And I'm looking at that from right here, sodium hydroxide and the nitric acid. So I do a double displacement on that. So I take the Na, and that goes to the NO3, and the H goes to the OH, right? So I end up with an H2O plus the NaNO3. Similar to what I had before. Okay. Now I know that H2O is going to be a liquid, and the NaNO3 ends up being aqueous. Come back here, and I'm going to have an H2O liquid and an NaNO3 aqueous. This, take this and dispose of it and put that in there. I have my sodium acetate. My sodium acetate right here. And the 3 molar sulfuric acid. This is a sulfuric acid right here. So I want to check the temperature. No change in temperature. So NaNO3. I have the wrong formula for NaNO3. This one and this one. So. Two colors, liquids, temperature change, mixing. So there's no observable change here. And if I look at the reaction between sodium acetate, which is NaC2H3O2. So this is the acetate. Oh, sorry, can't see what I'm doing. This is the acetate ion right here, the C2H3O2, and then the Na, and then the sulfuric acid, which is H2SO4. If I were to do this reaction, I'd be looking at Na going with SO4 and the H2 going with the C2H3O2. Okay, so if I were to have a reaction, I'd have to go with the Na2SO4 plus the C2H3O2. So I'd be making this acetic acid again. And I'd end up with 2 of those. And I need to have 2 out here to make the 2 NAs. And then I'd end up with 2 acetates and 2 protons because of what I have here. So those are the products I'd end up with. But I know that this is going to be aqueous because all sodium ions are aqueous. And I know that all the acetate ions are aqueous. So there's actually no reaction that happens there. There is no actual reaction that I would get out of this. So there's no reaction occurring. So that's what I have. Minimize this, zoom out this, take this out, put this in here, and then dispose of that, and then say go to the next phase. Woo! So we're going to balance the reactions that we did see. So the sodium carbonate and the nitric acid. So Na2CO3. So I've got 2 NAs on this side. I need to have 2 NAs on this side. So I put 2 out there. And I have 2 NO3s over here. So I need to have 2 NO3s over here. So I put a 2 out there. I have CO2 over here, CO3 over here. Okay. And an H2O. So just looking at what I've got, what I'm looking at. in terms of my balanced reaction. When I was looking at this before, I had Na2CO3 plus HNO3, okay? And that gave me an NaNO3 plus H2CO3, which gave me H2O plus CO2. I only needed to have 2 of these, and I need to have 2 of those. And of course, if I did that, that would give me 2 H's there. Then I'd end up with 1 CO3 and 1 CO3. That would then give me 2 there, 1 CO2. But so I think that works. This equation here. 2 HN3, 2 NaNO3, and H2O, and CO2. That looks good to me. Hopefully I have balanced that correctly. Some stuff. And then I have my NaOH, 1 Na and 1 Na, OH, 1 OH in there, 1 H in there, 1 NO3 and 1 NO3. So I think that's good. Cool. Love when I do this right. So to a clean test tube, add a piece of metal, iron, and 3 molar sulfuric acid. So here's my iron. So I'm going to take a forceps, pick up a piece of iron, and drop that in there. So you can look and see there's a piece of iron that's in. And then I'm going to add, there's a piece of iron metal. Right. I see a piece of solid iron metal. Yippee. Examine the appearance of the solution. Okay. I'm going to make some sulfuric acid. That's a sulfuric acid there. What's in here? Put that in there. Like that. And now I'm seeing bubbles being formed. It appears to be hot. Weird. Solution. Warm bubbles. Needed solution. Put the R out there because that doesn't belong there. So bubbles forming the mixture. Test tube feels hotter. So what did I make out of this? Now this is a single displacement reaction because I only have the Fe over there, right? So it's this kind of reaction. And so the metal is the Fe. And I have my the acid that I'm working with, H2SO4. So okay, I have an Fe solid. What's that? H2SO4 aqueous. And it says that the zinc is higher than copper on the activity series. Therefore, the zinc will displace copper. Okay, and so we're going to switch the metal with the cation, yada, yada, yada. Now, when we looked at that activity series, we see that Fe and H, those are the two we want to compare. So where is the Fe? Fe is higher than H, and so there should be a replacement there. Okay? So if I look at this, I see that I have Fe plus H2SO4. So what I should be seeing is that I have an FeSO4 plus H2 gas. something along those lines. And so I look at this and I say, okay, FeSO4 aqueous plus an H2 gas. And I think that's what I'm seeing. I'll zoom out. I'm going to dispose of this and I'll get rid of that. So cool. Now I need to get some calcium metal. This is my calcium. Put that in there. Calcium solid, and I'm going to add some hydrochloric acid to it. And that's this right here. Put that back in there. And again, I see bubbles forming, and it's hot. Solution. Bubbles and heated solution. And so I'm adding that HCl to it. So I'm making H2 again. And then I've got the CaCl2 because it's the CH2 plus that I'm going to form and a Cl2 that are going to come on that. Minimize this. I'm going to come out of here. I'm going to dispose of this and put that up there. Now I have iron again. So pick this up, put some iron in there. And then I'm going to add some copper to sulfate. Copper, that in there. And I'm going to look and see what this is. Check the temperature. And it doesn't look like anything's happening to me. So, solid, iron, metal, blue, solution, no bubbles, form, and no heat in tube. So no observable change, and so no reaction has occurred. And if I look at my activities here, I'm looking at that copper 2. So Cu is what I'm looking for. Cu is right here. And I have iron that's up here. Iron and copper. But the copper is below the iron, so I wouldn't expect anything to happen. So it's interesting to me that this is freaking out about that. So I don't see anything happening. Nothing appears to be happening. I've seen nothing. Test tube does not feel heated. Doesn't feel hot, doesn't get cold, no solid. And I don't know what you want me to see. I don't understand. Okay, fine. You're telling me that that happened. Okay, fine. So we're going to balance these equations. We have two H's there, two H's there. One Fe, one Fe, one SO4, one SO4. Looks balanced. Ca, Ca, H, H. So we need two of those. And that gives me two Cl's as well. One Fe, one Fe, one Cu, one Cu, one SO4, one SO4. Looks good to me. So it says that I did something wrong. What it doesn't like is this one right here. So it doesn't like this. Now, I don't understand what, I mean, Clearly it doesn't make the answer. Put this back in here. Listen, do this, and I'm gonna do this. And option heated. Bubbles. Hotter H2 and made FeSO. Okay, now we're going to put the calcium back in. And then chloric acid. Heat it again. Calcium. Solution tube is heated with formed. It's formed. Tube gets hotter. H2, CaCl2. What's the matter? And some CuSO4. Okay, it's doesn't feel heat. So I'm going to observe that it is less color. And metal solution. It's intense. Okay. Those are all balanced. And now it's happier, right? Okay. I don't know what, whatever. Fine. Lab is complete. I'm going to print this for my notes. Note that. Got it here, and I'm going to insert this printout. And hooray, I'm done with that. So I'm going to go ahead and stop sharing. And I will stop recording. I will see you guys soon. Thanks, guys.